It is day number 2 of learning Rust and doing the Linux toolbox and kind of getting it through. Like, I think we're really working on the terminal redirect to the secondary frame render today. We're going to see if we can't get that done. I think it should be fun. I got some ideas on that. We'll see on the redirect. I would like to get a little more progress and see if we can't get a few things. And we'll see how sidetracked we get as we learn more and more into Rust. It's quite fun. I'm really enjoying myself. I know it doesn't seem like we're making a huge amount of progress, but it's just we could probably make more as I learn more, but it'll be slow in the early days. Probably for the first couple weeks to a month of doing this, I think just anticipate a little bit of more slow growth. So that's kind of where we're at. How's it going, Lowbro Goat, the Wolf? Hope y'all having a fantastic day. It's a wonderful Friday. We are gonna have fun today. We are gonna have a lot of fun today. Can't wait. Can't wait. I was just thinking, I went to bed last night and I was like, man, Rust, common programming concepts, variables and mutability. It's just so interesting kind of going through this stuff, the data types. I probably should look at this a little more and how unsigned versus signed and learn that type of stuff. Very, very important type of things. But today we're going to just jump right into it, I think. That's the big thing is how to draw into the terminal and do like an output. This would be kind of fun. Because I think we started this at the end of the last stream and I was like, I think we can figure that out. We asked old Jippity, see how it goes. Time in Texas today is a little after, it's like noon 41. I did my workout a little early today. I just kind of went solo and ran up to the gym and then did some lifts and then just ran home. It was hot and sweaty and a little bit out of it. So, well, we'll see. there might be a reason why I don't stream on Fridays. I always do better later at night. So it being a little bit earlier on the stream and being Friday, it's not usually good. The only thing worse than that is a Monday. Yeah, but that's just how it goes. Oh, no better way to learn a cool project. I think that's the one thing that everyone forgets. Like a lot of people, I think, just wake up one day and go, you know what? I'm going to learn this language today. And what they need to do is go, you know what? I want to make this cool thing and have that thing be something that intrigues them. For me, it's the Linux toolbox. And I'm thinking, okay, well, Rust is probably going to be the best foundation for it. So that's the language I'm going to learn because it's more applicable. But I think too many times people get obsessed with like a certain language and then go, everything must be written in this. And I'm like, Like when I do the Windows toolbox conversion, I choose C# with mainly just for the .NET libraries because Microsoft loves integrating all that stuff. And I don't have to write nearly as much code because all the libraries already exist for interfacing with all the inner workings of Windows. So it makes sense to use that language. If you try to use Rust in Windows, it would be just a complete disaster, even for someone that was a master at Rust. It interfacing with the inner workings of like Task Scheduler and other things. A lot of times they just don't expose the APIs or tell a lot of these languages how to interface with them. So everything has to be written from scratch. It could still be done, but at the same time, I'm going to be able to do more work on like C# with .NET than someone that's programmed in Rust, since it's exception and it's just an exceptional programmer. I'm still going to beat that person because I have all those libraries and it's just what it's designed to do. So that's, I think, a very important thing, that a little misconception I see maybe some young folks make. And old folks too, honestly. There's some guys that like, I'm going to write everything in C. I'm like, hey, I get it. What can the tool do? Well, let me show you. Let me show you what it can do right now. It's amazing. Life-changing. You ready for this? Here it goes. Here we go. You can do J and K to navigate the menu up here. And then you can also use up and down arrows. You click this, it can kind of clone the library. That's what it can do. So not a whole lot. That's where we are. That's where we are with the program. Humble beginnings. Very humble beginnings is what this program's going to be. We'll see. Come back in a year and ask that question again. It's all about just chipping away. Just chipping away at it. The year of the Linux desktop. It's here. It's here. The toolbox is going to make it happen. So yeah, that's what we're going to do. So let's get that output redirected to the terminal. That's the first order of business. We need to redirect to the command block in the Rust application. You need to capture the output of the command and render it within the command block. Here's how you can modify the code to achieve this. Let's check our libraries. It needs the stdr str. Okay. And then it also needs process command. So let's just say that. Let's add these libraries. Right now, they're not used. So that's why it's like, hey, why did you add these unneeded libraries? It's kind of cool. And then we're assigning a variable output to specify the bash command, which actually I think is already done in here somewhere. Where am I handling that? Yeah, it's actually handled down here. It's actually doing the process command and then doing this whole shenanigans down in this section. So what we're going to do is just put that output. I think we're going to actually name this bash output and change a few things. This is cursor.sh is the actual editor there, Cirrus. It has the old Jippity built into it, and you can actually change it to like local LLM models and other things. Essentially what I use it for is when I hit Control L, it brings up this chat panel, like right here, this chat panel, and I can just ask it whatever I want. And then it's just going to spit out GPT stuff. And then if I like have a specific line of code and I'm like, hey, change this line of code, I can hit Control K and then just direct it to only look at this line of code and then just do what I want it to do to that line of code. So it just is an easier way to change or get suggestions, and you can accept and reject the, yeah, I will. You can kind of see, okay, here's the things that's going to change. It makes it a lot more useful because more often than not, old Jippity hallucinates and gives us some wacky answers. And since I don't know jack about Rust, I don't know it's hallucinating sometimes. I rely on Twitch chat to tell me it's hallucinating. So that's why I do what I do. Now, this one, why does it not expect an item? So can you do a global variable outside of a function in Rust? Genuine question. I think so, right? Or maybe this is, I don't think you can actually. I think this main Rust one right here, I think this is all within, it wants to do all of this within the block right down here for when my bash is selected. That's jank. I don't like that at all. Let's go bash output here. So yeah, we'll do bash output. Is there such a thing as global variables in Rust? Let's ask. We'll just do a new, we'll come back to this here in a second, but let's just do a new one. Kind of curious. Can you do global variables outside of functions in Rust? In Rust, you cannot declare or initialize non-constant variables at the global scope using a regular variable syntax like you might in other languages. Good to know. Rust requires global variables be constants or static. Here's how you can define them. Use const for values that are true constants, known at compile time and not changeable at runtime. Okay. Be okay with that, but obviously not there. Static variables are values that can live for an entire duration of the program and can potentially be mutable. Yeah. Okay. I don't really care about it being mutable or immutable here. But these are just really basic. So what about actually doing that? So the code snippet you provided attempts to execute a shell command and capture its output, which involves runtime execution and thus cannot be used in a global variable outside of a function. Yes, that makes sense. If you need to use this pattern globally, consider wrapping it in a function and using a lazy static initialization with the help of a crate like onecell or lazy static for complex initializations. Here's an example of using lazy static. Interesting. Uh, Lazy static. That's something. That's the first time I've heard that. Would it be better to use lazy static or just make a function bash underscore output? Choosing between using lazy static and defining a function like func bash depends on the specific use case and requirements. Using lazy static, the pros would be the command is executed only once and the result is cached for the lifetime of the program. This is efficient if the command's output doesn't change and is used frequently. It's not really. I don't really care about it being cached. Thread-safe initialization is guaranteed without needing to manage synchronization manually. Don't know what that means. Cons. Memory is occupied for the entirety runtime of the program, even if the data is used infrequently. Yeah, it's infrequent, so I don't think that's lazy static would be appropriate in this instance. Initialization happens at first access, which might unexpected impact to performance and runtime if not planned for. Yeah, I think just using function bash output and just making this more modular is the way to go. The command is executed every time the function is called. Yeah, that's the way to go. That's so weird that it just grab a crate and that's the recommendation from Jippity. Huh. Yeah. Good thing I have a brain. Asking the important questions instead of just pasting it in. Goodness, that would get you in a lot of trouble real quick. Yeah. So recommendation, use lazy static if the output of the command is static and changes very infrequently and is used multiple times throughout your application. This avoids overhead of re-execution and ensures that uses of the data are constant. Very interesting. I mean, I love the idea of lazy static for certain functions. For this one, it's completely not applicable. You'd have to be on crack to use lazy static to do a bash output and issue an sh command. Obviously, this is a function. It's a very interesting crate that I've never heard of, and just the usage of it kind of gives me ideas for the future if I want to make something more modular that's called quite a bit and gets like cached. Yeah, so very cool. Nice. Here's how you might define the function for flexibility. Nice. I think that's good. So I think what we'll do is just apply this section. Yes. It didn't change anything else, did it? Oh, yeah. Wait, what? Why? What? Why are you adding another one down here? Don't do that. Oh, weird. Why? Wait, why would it want another bracket? Huh. Speaking of AI coding, have you checked out GPT 4.0? Yeah, not yet. I'm waiting for the implementation. Maybe. Oh no, we got 4.0. We can do 4.0 today. Here we go. 4.0. Let's roll. We're doing 4.0 today. Let's see if it improves our output. So, old Cursor already implemented 4.0. All right, we're supercharging the AI today. Ultra AI professional coder incoming. Oh, let's see here. Future Highway. It's also depreciated in favor of features added to STD and once_cell. Oh, so lazy static's probably not the way to go. I don't understand what this is doing right here. Document what this result and error is. Error statement does. What does that do? Okay, this is what the function does. Okay, the result vec u8 stdio error on success returns the standard output of a command as a vector of bytes. On failure, it returns is interesting. Okay. Is vec u8 and std io error needed when making the function? All right, here we go. The return type vec ui is appropriate for the bash output function because it captures the potential for both successful execution, returning the command's output as the vector, and failure, returning as stdio error. However, if you want to simplify the function and you are sure that you will handle errors within the function itself, i.e., by panicking or logging, you could just the v8 or do the vec vu8 or another type. But generally, it's good practice to propagate errors to allow the caller to handle them appropriately. Here's a function with the current return type. If you want to handle errors inside the function and return just the output, you could do something like this. I like this better. Am I crazy? I feel like that's the way to go. I feel like that's weird. This one right here, I feel like that's just strange to me. I like this one better for the output. Because one, I kind of want to output it to terminal and feel like that's going to strip it out on my output. So we're going to go with this one. All right. I wonder why it adds this at the end. Like, why? Let's hallucinate again. It's just strange is all. Where's peasants only mode on YouTube? Yeah. Well, there's Chatterino. So like if you're on YouTube watching me right now and you want to chat, pull up Chatterino. I absolutely love this program. I like it better than using any web browser, whether it's directly on Twitch or YouTube. Like, I don't know what it is, but I just like chatting, doing this method with the app. And if I was like really wanting to be efficient, or maybe I was at work and I wanted to hide it a little bit better and I didn't want a dedicated application, I would just put it directly in here. And I think it's like WeChat. Let's Paru WeChat. Let's say you're a Linux user, WeChat. And then you can grab this. And then I would probably put and do the auth and auto login directly within WeChat. And then instead of using a Chatterino, I'd probably kind of do it in a terminal so then I could easily just bloop, 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 bloop. And then I wouldn't even have anything open, and maybe even do like multiple tabs. Just to give you guys some ideas of better usage of live streaming in general and chatting. The downside to doing the terminal approach is emotes. So if you're a big heavy emote user, Chatterino. If you're not an emote user and you're kind of like a boomer like myself, probably WeChat and terminal. Just my 2 cents. All right. I think most people would do the first one. Okay. I mean, this is good. I'm just giving you my impressions as a complete noob. So if someone, most people in chat probably will have more experience than Russ than me. So I do appreciate the feedback and why you go a certain way. I like that kind of readout. Are you paying for Cursor, or is it a whole AI stuff on the free trial? So Trixie, they on Cursor, they give 3.5 for free, but obviously for 4 and 4.0, what you need to do is you either need to subscribe to them, or they do have an option to put the OpenAI key in. Now I'm doing a lot of requests, so doing an OpenAI key is probably not in my best interest. But if you're only using this every once in a while or sparsely, I wouldn't subscribe. I would just do an OpenAI key and use 4 and 4.0 as needed. So if you're you find yourself only doing it, maybe once every couple days or something like that, don't subscribe. Just do the OpenAI key. That way you can use the latest and greatest 4. And I think the free model has some usage of 4, but it's really limited. So I would just do the key and then just have a separate subscription directly with OpenAI where it charges you per use. Can we add Alpine to this toolbox? Yeah. Oh, the sub is $20, just like OpenAI. All right. Let's go. All right. So we got this. let's go back in our history. Let's pull up the history. I'm going to flip back to our last one. And now that we got the output string here, str from UTF-8 output std unwrap failed to read output. I need to integrate this into this one. So we have the bash output right here. How's that being called? Output str. Let's take a look on the command block. Nope. Render. Yeah, this is where I'm kind of wondering, how is it utilizing output str? We're looking at that, so it has to be called within here somewhere, and yet I do not see it. So we have the chunks right there. That's drawing the area. You have the command block, which we've already established. That's done on the terminal draw. Now output underscore str contains the command output as a string, which you can render in the command block. And yet, there it is. Right under render widget, output str is being called, and then command block's being called. And then the output right here is being called within output str. Ugh. It's kind of wild. Yeah, that is interesting. Looking at this, I'm like, all right, I think I got a good grasp on it. Just thinking on how I want to structure that. This language doesn't look too sane. How is the AI extension called? I don't know. It's all integrated, so it's not an extension that's just built into the actual app. Now there is one on VS Code you can use to accomplish the same thing. I think when we were doing the independent LLMs, we were using VS Code, and God bless, I can't remember the extension's name that you could call different LLMs, which was kind of cool. The cursor program is just a fork of VS Code, but they baked in this instead of making an extension. I wonder why they did that. I don't know enough. I just like it. That's all I know. I should have contacted them and be like, do you guys have an affiliate program? Use my affiliate link. That is if I was using the big brain, but nope. No such luck. All right. Let's take this, right? I think what we're going to do here. Oh, no. What happened? Come on. There's a bug in this cursor, too. Oh, no. It messed up now. All right. Well, fun while it lasted there. We're on our own. So from here, we have this. Now, process command, I think we actually pull it up from here now. I think now this is redundant. The use process command, I think that's getting called twice. So instead of that, let output, no, that doesn't seem right to me. No, let's come back. Let's output string. See, this is not being called correctly. Because output, yeah, I see. I feel like breaking this function out a little bit better for clarity. Otherwise, I'm just going to put it all in here. Let's do this. And, if we do it this way and then, here we go. Let's grab this section of it. Pull that output. So that looks good to me. And then we have this. And then the output string, obviously not being used yet. Then we have the terminal draw. I kind of want to handle that down here, though. And then called. So we're calling this right in here. So instead of this, we want to call the function. Call the, what did we call that function? I think it was bash output, wasn't it? Bash underscore output function. Actually, I want to make that my bash output because that's the project name. Yep. All right, now we got my bash output. And then I want to see my bash output function generate. Chris, you really were better with C than Rust. C is just simple. Nowadays, I love working with compiled languages. C and Rust are my favorites. Yeah, probably. I mean, somewhere in my brain, I had 3 or 4 years of C++ back in the 90s. But I couldn't tell you anything. I just remember, I wasn't like, oh my gosh, super experienced. This is back when I was a teenager, you know, so quite some time ago, and definitely the 90s. And that I got to like memory pointers and some of that association, and that's kind of about where I stopped with C++. I did some pointers, but not many. When it came to memory management in C++, that was a whole different beast, and I was going on to, I think, like community college or whatever before dropping out altogether. And I took up some classes in programming, and I did okay, and I liked it. It's just I dropped out before, the 2000, before the turn of the millennia. So somewhere in my brain there is leftovers. I couldn't tell you what those are. So all right, we're calling this output function, and what I want out of this, if we're doing the my bash output, I want to kind of isolate all the things that my bash is doing right in here. So this command doesn't need to happen. And then this terminal draw frame, I want to keep this. And I think we can do that. So we have it right here. And then the command block right here, which doesn't really change. The only thing that gets added is right here under the render of the terminal widget. The output string and command block is really the big thing. So for this render widget, I think we can just do like a paragraph, my bash output, and then do the style. And that command block, yeah, I don't think I can call the function directly within the frame render. All right, Phoenix, we'll take a look on the PowerShell. It's okay if you don't want to answer. Does a man like you living in Texas own any guns? Most times, yes, I would say to that. Most people in Texas have guns. Nowadays, it's really hard to get knowledge from forums because you just don't have a good enough understanding of that. Like, I'm learning FFmpeg and OpenGL with Qt. It is so difficult to find resources. Most of the forums are just, you're not good enough. It won't be optimized. Just use this or that. Read the effing manual. That's true. I'd say that's very true, Blade. There's a definite weirdness to. I think it's more pronounced in the Linux community that they really don't like a lot of new people. It's almost discouraging to new people in general, which is unfortunate, but I understand it too. All right. What doesn't like this vector? Mismatch types. Struct vec u8 implicitly returns as a body, no tail, or return expression. Yeah. So if I want to break this out into a function, let's ask Jibbity. I want to break the my bash out into its own function. What does that look like? Yeah, gatekeeping is an art form. I've actually run into a lot of people in the programming community. It's actually been probably one of the most welcoming communities, I'd say. Because a lot of times I'm just sitting here pounding around, and even my weird views on AI being worthless for the most part, except for maybe some basic documentation as a crutch to learn. They're pretty accepting, I'd say. Almost all the programmers that have popped into chat and they're like, hey, I want to help you out, and they'll just contribute code. I'm like, man, that's kind of cool. All right, use cross term. What changed here? Okay. You can define a function that captures the output and returns it as a string. Then you call this function within your main event loop. Here's how you do it. Okay. Okay. I was doing it wrong. So that makes more sense because we want to return just the string of the output. Paste. So then we have it as a string. The big thing here, what about this output? Does it just have all of it baked into one string with like breaks and everything? It's kind of my thought. All right, oh, that looks pretty good. Just looking at this now that this changes a little bit, terminal clear. Have you seen the old school Winamp is going to be open source this September? Oh, that's cool. What was it? If you're on Linux, you can just pull up there's a Winamp skin for Winamp skin Linux music. What was it? Audacious? No. There was another one I was using. It wasn't Audacious. What was it called? I want to say it started with an L. QMMP. Yeah, never mind. I was off. That was it. QMMP Winamp skin. That was the one I was using. Qt based music player. Look at that. I like this one. Let's see. Let's go Winamp. Here we go. This. Bam. So it's built like this as a stock, but then you can actually change the skin. And I want to say I liked this iteration of it a lot better. Where are you at? Yeah, there you go. There's the old school. Here's an XMMS skin. I think that's the way I did it, and it had the closest like look and feel of like old school 90s Winamp. That was the one. It uses the native Winamp scans. Okay. Yeah, because I tried the Audacious one, but it just didn't feel quite like the old school Winamp, where this one was very, it just felt right. Like the Audacious one kind of and this one I remember was like, as soon as I found it, I was like, that's cool. Now I just got to figure out how to download MP3s again. Snapster still a thing? Oh man, let's boot up some LimeWire. Oh my god, I remember cleaning so many computers from viruses in LimeWire. So great. I don't remember Winamp being so good. I mean, Winamp was solid. It was a solid MP3 player. So we changed that. What other changes? Here, let's just apply this. Just see what. Let's go continue. It's very close. That's kind of interesting how. Okay. So we'll hit apply here. Let's see what changes. Okay, you have the command that goes from my bash output to command output. And then this over here goes write new paragraph command output as string block size. Okay, that looks good. Chunks, this changes a little bit, but not very much. Chunks 0 for the stateful widget. Yeah, because we don't want the stateful widget to be in the terminal. That makes sense. And then that looks exactly what I wrote earlier. No changes. It looks like just indenting it. And then we have mutable command output. Yeah, that makes sense. It's going to change. All right. Accept. So looking at this, let's see what errors we have. It really likes to throw like an extra bracket in. It's kind of odd at the very end here. I mean, if that's the only hallucination it made, the rest of it actually looked pretty solid. Not a major change or like a giant refactor that happened. Like sometimes it likes to do. So I think we run it, see what we get. Do we have the redirection of the output? Well, let's go ahead and clean the project just because we did add some different libraries. We'll run it. Okay. It's kind of interesting it condensed that. All right, so if we do my bash, yeah, it doesn't run. Any improvements after changing to GPT 4.0? I don't know if it's improvements, but it does seem pretty good. It didn't change nearly as much as stuff, which is good. Sometimes GPT likes to just be like, I'm gonna do everything. All right, let's make this constant 2. The item's length was off, so this actually should constraints. That for some odd reason it didn't give the proper constraints. Let's just launch it over here. Okay, now it did. Okay, and it's just not accepting the inner command. Okay, 4.0 is the same as 4, except faster. I think 4.0 should be better. It should be more accepting of commands. So this exit loop and close. Did we get this? Maybe there was something with the loop and it just didn't quite grab the end of it. I think it was just missing some of this at the end. I really think this is what happened with the execute and mutable screen. So let's accept this. And again, it adds this at the end, which is weird. And then we have, yeah, let's just accept that and accept that. So we're just kind of changing the queue location to be up here. Honestly, the quit item will probably change to something different. Yeah, so 4.0, let's see if this fixes it. And then we'll say if this fixes it, I'm going to say 4.0 was an improvement over 4, because 4 yesterday was kind of a shit show. It was not great. It was just kind of giving me anything and everything. This seems much more bite-sized and less of trying to rewrite the whole program and more of just sticking to what's already there. Let's see. So initially, no. Yeah, no. Okay, yeah. About the same as 4. Anytime I get into anything with any kind of complexity, it kind of falls apart. Oh, wait. No. Let's try it one more time. I don't think it's actually grabbing the enter key. We have selected and then we match the index, but it's not actually putting this here. So command output, I don't think it's actually running this command when it comes in. Let's just, we had some leftovers. Let's clear this out and then let's run it again. I don't think we're going to get anything different. We have proper ones right here, but enter doesn't do anything. That doesn't do anything. Q does quit. So yeah, Phoenix. So the thing that I'm doing is it's a little bit of both. I'm reading in the background. So obviously on stream, watching me read a bunch of hello world, here's how variables and constants work. It's just not good entertainment. That's why we're doing it this method on stream. Off stream, I'm actually looking at it, learning a few things, and actually reading some of the manuals. And you're going to see some knowledge come in a little bit each stream, and you're going to be like, okay, he learned about this now, but there's still like, I'm going to learn like 0.5% of what actually knowledge you need to know, and it's just going to chip away at it. So a lot of the stream is just hacking at the program, learning little bits and pieces during the hacking process. Not efficient at all. I understand that. And that's okay. And then off stream is when I actually read and do a more traditional learning model. And that's just how I'm approaching it. Yeah. And like you can do some things on stream when it comes to reading, like Vim Tutor is like amazing. Like when you're here and you do Vim Tutor, it's like, hey, wait, Vim Tutor does not exist. Okay, yeah. This is fun to do on stream because you can kind of walk through and you're like, okay, hold down the J key until it repeats. That's lesson 1. Here's how to exit Vim. :Q exclamation. All right, deleting. Move the cursor to the line at the end bar marked here. All right, cool. Use the X key to delete the unwanted characters. So then you just, all right, cool. Deleted. Let's keep going and then learning Vim. So like this type of learning is interactive in the lessons, and that makes sense. Programming isn't like that. It just isn't. And I can't exit Vim. But that's a difference though. So it just depends on how interactive the load can be. But if I was doing this like right now on the official rustlang.org, I'm on like data types. So learning about unsigned versus signed. And then I would sit here and read numerical operations. Okay. Boolean types. Got it. Compound types. All right. Now we're starting to get into things where I'm going to have to sit here and like focus and not say a damn word for like a minute. And that just isn't fun. Fun to do and not fun to watch. So, oh, Lovro, why doesn't Vim use IJKL like the rest of WASD? IJKL. I don't know. I kind of mixed that up when I first started too. because learning like J is down felt weird. I think a lot of people think J is up when you first start learning like the Vim motions. But after I kind of program my brain to think of J as a down arrow, it actually helps. So J actually kind of looks like a down arrow. So if J's the down arrow, then K has to be the up arrow. And then L's all the way to the right, so that's going to go right. And H is all the way to the left, so that has to go to left. And that's kind of how I remember Vim motions. And that kind of got me started. And it's ergonomics too. Oh, wow. He read the whole NeoVim manual live. It took 10 hours. Wow. That's crazy. Well, maybe I could read it. I'm actually not bad with reading. That's why I try to think through some of these issues as I go along too. Maybe we just read the whole Rust manual. Let's do a poll. I think that's what we do. You guys decide. You're the one watching this. Do you want to see me read the Rust manual? Or would you like me to sit here, pound around, hack at this? I think that's how we go. Let's just do that. We'll see how long I last. Well, let's wait. You guys got to make the decision. I leave it in chat's hands because I'm cool with either way. Because I have a very basic knowledge and I do need more of the base knowledge. Should I read the Rust manual instead of hacking at GPT in this project? Read the effing manual. Hack around, you AI shill. Okay, that's a little bit derogatory. I'm obviously leading. That's a leading answer. With cursor to improve the project. So I think that's good. Anybody okay with those answers? Or should I name them differently? Any questions with those answers? All right. You can't pick both. I guess we could do a chapter and then hack around and then do both. All right, we'll just do both. Both. Give you 3. There you go. Let's create that poll. And we'll share it. Copy it. Bam. And I'm just going to say both. Sure. I'm good. So there is the link. Go ahead and vote now. Let's see the results come in. What is more entertaining for you guys? Y'all decide. Oh, both's pretty good. I like that. It's kind of funny that the RFM and hack around's almost equal. RTFM, yeah, that's there. Well, so last time, Blade, when we did the straw poll, I let you guys decide the language and then everybody picked Zig. So my faith in chat is a little diminished. As I was going through Zig, I was like, oh, wow. Yeah, this language is kind of cool, but man, there is just not a whole lot of documentation out there because it's so new. I think it was created in 2016 or 2017. So very, very young language. I'm not going to lie. My first drunk Arch tutorial was your drunk video. Needless to say, I got a little confused. Oh man, that's terrible. That video had some really like glaring errors. The first being, I think I mixed up my display managers and I was using like, instead of using like SDDM with KDE, I think I ended up using LightDM with KDE, which you don't do. You just use SDDM if you're going to do KDE. And there was like, oh man, I tore it apart. I think I actually did a reacts video to that. Oh, let's get back into the Rust. Side detour there. Sorry, I was like, hey, let's make it happen. Let's go through reading about data types, specifically what each one does. Every value in Rust is a certain data type, which tells Rust what kind of data is being specified so it knows how to work with that data. We'll look at 2 data type subsets, scalar and compound. Keep in mind that Rust is statistically typed language. which means that it must know the types of all variables at compile time. The compiler can usually infer what type we want to use based on the value and how we use it. In cases when many types are possible, such as when we convert a string to a numeric type using parse in the comparing the guess of the secret number section in chapter 2, we must add a type annotation like this. And that would be like the U32. If we don't add U32 type annotation shown in the preceding code, Rust will display the following error, which means the compiler needs more information for us to know which type we want to use. All right. Lots of reading. This will be a boring stream. Did I not warn you? I warned you. This is what you asked for. Oh, is the title still day one? Let's fix it. Do I need to do another poll? I said, let's hack around. Yeah, I think that would be much more entertaining. You said, we want you to read. I was like, hey, all right, I can read. I'm pretty good at that. This is fun. Go on. No takesy backsies. All right, we're going to continue. Let's at least get through the data types, okay? And then we'll do a poll. We'll do a poll and see what you guys would like to change. This is not, it's a pretty short section. We got maybe 5 to 10 pages here. That shouldn't take me but 5 to 10 minutes. But if you leave and I do the poll, you're not here. I might just be reading for the next 2 hours. So there is some incentive to stick around, even though you might be bored to tears learning about data types in Rust. The people that voted for reading went to grab popcorn. This is true. This is true. The Rust book really starts simple, and then it gets to async and threads, and it's way harder. Perry, it's a lot like as soon as we transitioned to, I used to get a lot of commits on like the Win10 script and the old Windows script when it was just a simple PS1 file. But once we made it modular and we did run spaces, which is also async and threading, everyone dropped off the map. Like commits to the main project, not just like, hey, add my application, you know, really simple commits. We get a lot of simple commits now, but we get almost zero like, hey, I want to change the main functionality ones, because people look at the code and they're like, oh, what are you doing in PowerShell script? I didn't know you can convert XAML file and build an entire GUI doing run spaces and threading in a script. That's kind of insane. And I'm like, yeah, I know. How does that work? I'm like, yeah, I kind of know, but it's really, really complex. So it's kind of the same thing. So yeah, we'll see how far we get. 2 pages per minute. How fast can I read this? We can get it going. I won't be able to understand what's going on. I will see the stream and join other topics than LinUtil. Yeah, I think the big thing here is making the foundation and then launching into Bash. I think there'll be some things about LinUtil you won't be able to get Igor, but there will be things that will be able to be done, such as, hey, it's just launching a Bash script to do this section of it. Okay, getting backlogged. All right, here we go. Let's get through it. Let's see how fast I can read now, and we'll get going. A scalar type represents a single value. Rust has 4 primary scalar types: integers, floating point, numbers, booleans, and characters. You may recognize these in other programming languages. Let's jump into how they work in Rust. Integer types. An integer is a number without a fractional component. We used one type integer in chapter 2, the U32 type. This type declaration indicates that the value is associated with should be an unsigned integer. Signed integers types start with I instead of U. Okay, so signed is I, unsigned is U. This takes up 32 bits of space. Table 3.1 shows the built-in integer types in Rust. We can use any of these variants to declare the type of an integer value. Okay, so then we got our table here. Length, signed, unsigned. 8-bit, 16-bit, 32, 64, 128. Okay. I wonder why you'd need to go to like these really high up bit types for integers. Doesn't seem like those would get used very much. Usually I see like 16 and 32 used in most other languages. Anyways. All right, here we go. Each variant can be either signed or unsigned and has an explicit size. Signed and unsigned refer to whether it's possible for the number to be negative. In other words, whether the number needs to have a sign with it, signed, or whether it will only ever be positive and can therefore be represented without a sign, unsigned. Okay, so signed, whether the number needs to have a sign with it, unsigned, without a sign. But unsigned's for positive. Okay. It's like writing numbers on a paper. When the sign matters, a number is shown with a plus sign or a minus sign. However, when it's safe to assume the number is positive, it's shown with no sign or unsigned. Signed numbers are stored with two complement. What the hell is that word? Two complement representation? Okay. He needs to act excited. Okay, all right, here we go. I'm getting excited. All right. I need to do a little bit more with my inflection. I look forward to the feedback from chat. All right. Here we go. Get a little more excited. Each signed variant can store numbers from -2 in -1 and 2 in -1, -1 inclusive. Did you get that? I sure as hell didn't. Where an n is the number of bits that variance uses. So an I8 can store numbers from -2 to the power of 7 to 2 power of 7 and -1, which equals -128 to 127. What the hell am I reading now? Like, what normal human goes, yes, that makes complete sense. Thank you for explaining that for me. Maybe I'm just a simpleton and I don't understand any of what I just read, but this, okay. You had me at like, okay, if it's only ever positive, it's unsigned. Okay, that makes sense. This, okay, signed if it like has a negative value, get it. And then this gook. What? Oh my word. So Sunrise, thanks for the bits. All right, here we go. Back to it. This section, yeah, we're just gonna pretend like we know what we're doing. Oh, wait. We might have some transition in chat. Think of it the same way as you think of bit masks, not numbers. If you write assembly, you definitely need to know that. Okay? I don't write assembly. I'm a Jippity programmer. I'm a programmer and this is making me feel stupid. All right. Okay, enough chat. Let's get going. We still got a little bit to read here. Additionally, the I size and U size types depend on the architecture of the computer your program is running on, which is denoted in the table as arc or architecture. 64 bits is your 64-bit architecture. That makes sense. 32 bits, your 32-bit architecture. You're mostly going to be 64 today. Very seldomly will you ever see 32. You can write integer literals in any forms, such as table 3-2. Note the number of literals that can be multiple numeric types allow a type syntax, such as 57U8 to designate the type. Okay. Number literals can use an underscore as a visual separator to make the number easier to read, such as 1_000, which has the same value as if you specified 1,000. Oh, that's kind of weird. I guess for readability, if you have like a million with 1 and 6 trailing zeros, I guess it would be a little bit readable if you broke it up with underscores, but that's interesting. Okay. I had to read it about 10 times to get it. All right. So now we have this. So you have your basic decimal right here. which is 98,222. Or no. Is the underscore? See, it's listed as that, but this decimal, I guess decimal is still just a dot, but the underscore is representative of a comma. Hex is 0xFF, octal 0O77, binary, 0B to specify binary, and then just 111 underscore 000. So, okay, makes sense. Byte U8 only, which is B apostrophe capital A apostrophe. Okay. It's like a comma. Okay. Interesting. So how you know which type of integer to use? If you're unsure, Rust defaults are generally a good places to start. Integer types default to I32. The primary situation in which you'd use iSize or usize is when indexing some sort of collection. Okay. Makes sense. Let's go integer overflow. Let's say you have a variable of a type U8 that can hold values between 0 and 255. If you try to change the variable to a value outside that range, such as 256, integer overflow will occur, which can result in one of two behaviors. When you're compiling in debug mode, Rust includes checks for integer overflow that cause your program to panic at runtime if the behavior occurs. Rust uses the term panicking when a program exits with an error. We'll discuss panics in more depth in the Uncovering Errors with Panic! Section in Chapter 9. When you're compiling in release mode with the -- release flag, Rust does not include checks for integer overflow that cause panics. Instead, if overflow occurs, Rust performs two complement wrapping. In short, values greater than the maximum value the type can hold wrap around. Everybody likes the wraparound. To the minimum of the values the type can hold. In the case of U8, the value 256 becomes 0. The value 257 becomes 1, and so on. The program won't panic, but the variable will have a value that probably isn't what you were expecting it to have. Relying on integer overflow wrapping behavior is considered an error. Okay. To explicitly handle the possibility of overflow, you can use these familiars? What is that word? Families. Why does families look weird to me? Is that a word? Yeah, Rust audiobook. This will put you to sleep. Okay, yeah. That's the plural noun for family. Okay, so it's just families. Titus doesn't know the word family. All right, here we go. News at 10. Do you have glasses? All right. Actually, I got LASIK. I used to have glasses. Good one, Perry, though. I've had LASIK for like 15 years. I was like late 2000s when I got LASIK. So I've been, 2009. I've had LASIK for 15 years. Still can see pretty good. Although, I don't know. I guess I could read back here. Let's get a little more comfortable. Here we go. All right. To explicitly handle the possibility of overflow, you can use families of provided by the standard library to primitive numeric values. Wrap in all modes with the wrapping _* method, such as wrapping _add. Return the none value if the overflow with the checked _ methods. Return the value with the Boolean, indicating whether there was an overflow with overflowing _ methods. So if you do checked _, it'll just return a none value. And then if you're doing overflowing, it'll do like a true false value. Interesting. Okay. Saturate the values minimum and maximum values with the saturating _% methods. What the hell does it mean, saturate the values minimum and maximum values? Okay. Mental note. Floating point types. Rust has two primitive types for floating point numbers, which are numbers with decimal points. Rust's floating point types are F32 and F64, which are 32 bits and 64 bit in size respectively. The the default type is F64 because of modern CPUs. It is roughly the same speed as F32, but is capable of more precision. All floating point types are signed. Here is an example of that shows floating point numbers in action. This is from a main.rs sample. You got function main, let x equal 2, which is F64. Let y, F32, equal 3. The F32 specifies that it goes to a floating point of 32. By default, it just goes to 64. That's good to know. Floating point numbers are represented according to the IEEE 754 standard. Thanks for the subderp. Let's see. The F32 type is a single precision float, and F64 has double precision. Did you get that? Double precision by default. Nice. Numeric operations. Rust supports the basic mathematical operations you'd expect for all the number types: addition, subtraction, multiplication, division, and remainder. Integer division truncates towards 0 to the nearest integer. The following code shows how you use each numeric operation in a let statement. All right. Let sum equal 5 plus 10. Let difference. Now, remember, all this is going to be immutable. So if you ever needed to reassociate this product, like down here, you try to do another let, it's not going to take it. It's just going to error out, or just, I don't know, it just won't apply it. So once you do 4 multiplied by 30, it's going to be 120 is what product will be for the remainder of the program, I believe, unless there's something we learn later that makes it mutable. But I'm saying it for myself to remember, because that's going to get me eventually. I hate manuals like this. You need an English degree just to read them. It's kind of like gatekeeping. Yeah, I mean, it's okay. I got another manual on the way. I'll read that one, though. I'm trying to make this at least as entertaining as possible. How am I doing so far, guys? Are we down to 50 people in chat yet? Each expression in the statements uses a mathematical operator and evaluates a single value, which is then bound to a variable. Appendix B contains a list of all operators that Rust provides. All right, well, what the hell are all the operators? Let's see. All right, operators. This is actually beneficial. This is in Appendix 21.2. You have the bang operator. It's a macro expression. And then you have... Okay, so this is actually trailing indent for a macro expression. If it actually starts with a bang, then bitwise or logical component, not equal to usually. Yeah, that's not equal to. Percent, arithmetic remainder. Okay. I think I was using that for like some type of rounding in a different language. Percent equals, authentic, arithmetic. Am I saying that right? Anyways, keep going. And percent borrow. So you can do borrow muted, borrowed expression, borrowed pointer type is the same thing with the ampersand types. Okay. Bitwise and assignment, ampersand equals. Yeah, this appendix, I know this seems crazy to read, but this is probably the best thing we can get from the chapter we're on. Like this, everyone knows. So this is super simple. There's not much here. They don't really need to spell all this out, I don't think. Like, they just went through this huge, crazy, long, hey, signed and unsigned, and then they felt like they needed to make this, which is really rudimentary. Pretty funny that they thought, hey, just in case you forgot. Anyways, sorry, I'm being nitpicky now. All right, raw pointer with an asterisk, like asterisk const type or asterisk mutable type. That's a raw pointer. I didn't know Rust had pointers. I guess. Okay. All right. I don't know what my thought was there, but it's gone. Moving on. Arguments and elements. Separator is a comma. Anything else in here that's kind of interesting? This is kind of a funny thing I haven't seen very much in languages, like this dash greater than sign. It's like an arrow. A function in closure return type. So if you wanted to return, like, I think it was like dot forward dash greater than sign, it was kind of interesting. Let's see, what else is there? Anything else that kind of jumps out at me that's like, ooh, that's a wild kind of thing? Okay, division, dir, constants, constraints, actually. Constraints with the colon sign. And then you also have loop label. I don't know what exactly that would be for an example. Might look at. You have left shift with the less than sign, and lots of variants of left shift after that. Equality is just equals equals. That's like on any other language. And then equals like greater than, less than, I'm sure, are there. It does look like it's only listing greater than on the equal sign. Oh no, the less than or equal to. So less than or equal to goes before the equal sign, greater than or equal to also before the equal sign. And then if it's equals greater than, part of match arm syntax. So you have to, okay, that makes sense. I could see how I could get confused there. Screw that up. Right shift. Pattern binding is the @ symbol. And then the pipe symbol here is pattern alternatives. Usually like an or, right? Dash dash or pipe usually is an or in like an if statement in most other languages. Okay, just thought I'd approach the reference because that would be actually something useful. Let's rewrite the whole Linux kernel in Rust. Actually, if you look up the Shida project, the Linux kernel is there, so that's a thing. Believe it or not, well, I don't think they're rewriting the Linux kernel specifically in Rust, but they are doing a lot of the reverse engineering on Apple stuff, specifically the GPU drivers in Rust. So a lot of that is actually Rust and Ashita. So if you do want to see like Linux implementations of Rust in like the core system, the Ashita project's really kind of amazing. I need to load it up on my M1 and do like a video on it. I just haven't yet. The Boolean type. As in any other programming languages, the Boolean type in Rust has two proper values, true and false. Okay. Other news, water is wet, the sky is blue. Why do I need to put this in here? Okay. Blah, blah, blah. All right, the character type. Character type is the language's most primitive alphabet type. Here are some examples of character values. Okay. Z colon char equals Z, but that Z looks a little weird. Maybe that's a different, okay. With explicit type annotation. Okay. Let heart-eyed cat, this is an emote, but it's not actually specified. Interesting. Note that we specify char literals with single quotes as opposed to string literals, which use double quotes. Rust char type is 4 bytes in size and represents a Unicode scalar value, which means it can represent a lot more than just ASCII. Accented letters, Chinese, Japanese, and Korean characters, emoji, and 0 width spaces are all valid char values in Rust. It's good to know. Unicode scalar values range from U plus 000 to U plus D7FF. It's kind of weird. Why wouldn't it be just like FFF? Anyways, and U plus E000 and U plus 10FFFF inclusive. However, character isn't really a concept to Unicode in Unicode. So your human intuition for what character is may not match up with what char is in Rust. We'll discuss this topic in detail in storing UTF-8 encoding text with strings in chapter 8. Damn, I can't wait. That sounds amazing. Oh my God. All right, compound types. Here we go. Yeah. We're almost there. We're getting close to the end of this chapter of data types. We're almost there. Compound types can group multiple values into one type. Rust has two primitive compound types, tuples and arrays. Am I saying that right? Tuples? Tuples. The tuple type. Kind of rolls off the tongue. Tuple. All right. A tuple is a general way of grouping together a number of values with a variety of types in one compound type. Tuples have a fixed length, one declared. They cannot grow or shrink in size, so immutable. We create a tuple by writing a comma-separated list of values inside parentheses. Each position in the tuple has a type, and the types of the different values in the tuple does not have to stay the same. We've added an additional type of annotations in this example. So tuple, let tup colon, and then you have the signed 32-bit integer, you have a floating point 64-bit, and an unsigned 8-bit. So it's almost like an array, but you're assigning different types to the tuple, using tuple. So then 500 would be signed 32, 6.4 would be floating point 64-bit, and then 1 would be unsigned 8. Interesting. I like it. Let me zoom in a little bit too, just so we get a little bit more. The variable tup binds to an entire tuple because a tuple is considered a single compound element. To get the individual values out of a tuple, we can use pattern matching to destructure a tuple value like this. fn main let tup 500, 6.4, 1. Then you assign let xyz equals tup. The value of y is, and then y. That's kind of interesting how it's specifying y. So it'd be 6.4 with the floating point 64. And then I'm used to like maybe like a dollar sign or something here, but in Rust, it looks like when you're printing it out and you don't want to break out of the string, you can just take the variable and put it within squirrely brackets, I'm guessing. All right. The program first creates a tuple and binds it to the variable tup. Then it uses a pattern with let to take tup and turn it into 3 separate values, x, y, and z. This is called destructuring because it breaks a single tuple into 3 parts. Finally, the program prints the value of y, which is 6.4. We can access a tuple element directly by using a period, followed by the index of the value we want to access. For example, all right, where in here? Oh, okay. Let 500 equals x dot 0. So the dot 0 would reference this, this. So it would assign 500 to that. Okay. Interesting. So it's almost like an array. Maybe I'm misusing that term, but that's kind of cool. I kind of dig that. So 6.4 is x dot 1. Let 1 x dot 2. I mean, that's pretty slick. So you're assigning this value. That's cool. Just remember, just like an array, everything starts at 0, not 1. Okay. Mental note added. This program creates a tuple x and then accesses each element of the tuple using the respective indices. As with most programming languages, the first index of the tuple is 0. The tuple without any values has a special name, unit. This value is corresponding type are both written in parentheses and represent an empty value or an empty return type. Expressions explicitly return the unit value if they don't return any other value. The array type. Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Unlike arrays in other languages, arrays in Rust have a fixed length. Let me read that one again. That seems important. Another way of having a collection of multiple values with an array. Unlike a tuple, every element of an array must have the same type. Unlike arrays in other languages, arrays in Rust have a fixed length. Well, that's weird. Why? We write the values in an array as a common separated list instead of square brackets. Okay, that looks okay. That looks fine to me. Use vectors for unfixed length. Okay, that makes more sense. That's why Rust uses vec all the time, isn't it? The fixed arrays are the standard since the 50s. Arrays in C have a fixed length. Don't use arrays. Use vecs, even with for fixed length. Arrays are hell in Rust. Okay, well, that's good to know. Do you use tuples very much, Perry? It sounds like Perry actually uses Rust, and I think he's contributed quite a bit and laughed at us. Although you might not have actually told me. I know you're laughing. But yeah, that's a good point. A lot of times people are saying, hey, don't bother. I mean, I do like the word tuples better than array. Just saying. It's just a fun word to say, tuple. Anyways, back to arrays. Yeah, I don't see a lot of tuples in Rust at an application level either. There are a few times you want a fixed array length since the memory layout isn't the same as my first meaningful project. Yeah. Vec bang 1, 2, 3, 4 includes a vec which values that can be pushed to. Okay. And the tuple is like a list that cannot grow or shrink. I say list instead of array since the values of a tuple can be different, but an array they cannot. I like that. Those are all very good feedback here. Tuples are actually useful inside enums because enums contain structs, and they are the structs that are just better tuples. Damn, I'm learning all kinds of things from both. I love the reactions to chat while I'm reading this. As much as I thought this would be a complete disaster, whenever I run into something I don't quite understand, or I'm like, why does this exist? Or why does it exist like that? I kind of like emphasizing it and then getting chat's feedback. It is actually kind of nice because it's like, okay, well, I can pretty much just ignore most of the array section since I'm not probably going to be using arrays at all. And be using vectors instead. Getting to the vectors, I see it coming up. Arrays are useful in what you want your data allocated on the stack rather than the heap. We will discuss the stack and the heap more in chapter 4. Or when you want to ensure you always have a fixed number of elements. An array isn't as flexible as a vector type, though. A vector is a similar collection type provided by the standard library that is allowed to grow and shrink in size. That's why you see them everywhere. If you're unsure whether to use an array or a vector, chances are you should use a vector. That's why you see vectors. Vectors are everywhere in Rust. Vec. You'll see it a ton. I've already seen it a bunch from old Jippity. It loves to use vectors. Accessing the stack is faster than the heap, though. So that's one. There might be some instances where you might want to use an array because it's faster. So it might not actually be a bad thing to specify as arrays for something that's never going to change. Like, let's say a menu. Instead of using it as a vector, putting it in an array and putting it to the stack would actually probably be more efficient. Just my shower thought of the day from my limited 3.2 chapters I've read. However, arrays are more useful when you know the number of elements will not need to change. For example, you're going to be using the names of a month in a program and you would use an array rather than a vector because you know it will always be 12 elements, January through December. You write an array type using square brackets with the type of each element, a semicolon, and then the number of elements in the array like so. Okay. All right. I like it. Here, the I32, or signed integer, is the type of each element. After the semicolon, the number 5 indicates the array contains 5 elements. So it's saying, here's your type. There's going to be 5 of them, equals, and then it gives each one separated by a comma. You can also initialize an array to contain the same value for each element by specifying the initial value followed by a semicolon, and then the length of the array in square brackets as shown here. Let A equals 3, semicolon, 5, all enclosed in square brackets. The array A will contain 5 elements, and they will be set to the initial value of 3. This is the same as writing, so it'd be 3, comma, 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 but in a more concise way. Also, this is not mutable, so it'll always be 5 3s. You really would never see this in the wild because of that, but it's still good to know for an example. ProMaster jumped out. He's like, are we still reading Rust? We're getting to the end. Look how close we are. We are so close. Accessing array elements. An array is a single chunk of memory of a known fixed size that can be allocated on the stack. Not the heap, but the stack. You can access elements of an array using indexing like this. So here's the array declared. Then you're letting first, and then very similar. That's very similar to so many other languages, so that's going to be a very easy one to remember. In this example, the array named first will get the value of 1. Because that is the value of the index in the 0 place, the variable named second will get the value of 2 in the index 1 position of the array. Invalid array element access. Let's see what happens if you try to access an element of array that is past the end of an array. Say you run the code, kind of an idiot, and you're like, hey, I'm going to try to access the 6th position of this array when there isn't one. Similar to the guessing game in chapter 2, to get the array index for the user, you set this all up. All right, great. The code compiles successfully. You run the code with cargo run and enter 0, 1, 2, 3, or 4. The program will print out the corresponding values as the index of the array. Instead, you enter a value past the end of the array, such as 10. You will see an output like this. Thread main panicked at source, line number 19, index out of bounds. The length is 5, but the index is 10. Note run rust backtrace 1 environment variable is a display of backtrace. Okay. There's a way to capture that, though. Usually you have some type of element, so when you're grabbing input from a user, it'll feed it through and say, hey, if it's not part of this value, it shouldn't panic because you'd actually put in some error handling. But I get it. The program resulted in a runtime error at the point of using an invalid value in the indexing operation. The program exited with an error message and didn't include the final print ln bang statement. When you attempt to access the element using indexing, Rust will check the index you specified is less than the array length. The index is greater than or equal to the length. Rust will panic. It'll freak out. This check has to happen at runtime, especially in this case, because the compiler can't possibly know what value a user will enter when they run the code later. This is an example of Rust's memory-safe principles in action. In many low-level languages, like C, doesn't say it, but that's what they're thinking. This kind of check is not done, and when you provide an incorrect index, invalid memory can be accessed. Rust protects you against this kind of vital error by immediately exiting instead of allowing the memory access and continuing. Chapter 9 discusses more of Rust's error handling and how you can write readable, safe code that neither panics nor allows invalid memory access. How we feeling? How we feeling about data types in Rust? Was this informational? All right, let's see. Let's go back. We got to run another poll now. All right, chat. We are done with chapter 3.2, data types in Rust. It is time to take another poll. Do we keep reading? Yes or no? Leave it in your hands. You are the masters of where this stream go. We'll hit share. And here it comes. I'm going to say no. But let's just see. Install Gentoo. We should do Linux from scratch. But again, if we get a yes, you know what I should have done? I should have made like you can skew the poll with like $1 or something. Oh man, I'd make so much money. There'd be that one person who'd be like, "Oh please, Titus, no more. I just want you to move on. Just get back to coding. Just anything else." And then there'll be that other person that's just like, yes, suffer. Oh, I love it. LFS right now would be content. Yeah. Oh, man. Well, this is a lot closer. I think chat's just 50-50 in me again. It's a lot closer than I thought it would be. I mean, that's kind of impressive, though. Reading Rust, what we got? We still got a minute left. We'll go till 40. We're going to go till 02, 42, 42. We'll go another 42 seconds because that's the meaning of life. So that's when we check back in. I'm not going to show the live results. I don't want to skew it one way or another. I don't want people jumping in and be like, well, there's more yeses than nos, and then clicking that. No, you have to vote. I'm not going to show, and I'm not going to look at it. So I don't want to influence the vote. It was close to 50-50 at the time I flipped off. You now have 20 seconds left. If you haven't got your vote in, get it in now. It's in your hands. It was boring, but we all learned something. I think that's a very good apt description of what just happened. Keep reading what? The Rust Programming Language Manual from rust-lang.org. All right, it's past the 42. The winner is... No, by 53%. We stop reading the Rust Manual. It is done. It is done. So close. So close. Now, I am on functions. But now, what should we do? I don't know. We could continue programming, but I kind of want to stop. I kind of want to read more. You guys, I've actually learned quite a bit there, and I'm like, oh, I don't want to kind of hack around at this anymore. So I don't think I want to hack around on the programming. I think we, oh my God, LFS. You want me to read more, is what you're saying. Is that really what you want? Was I that entertaining? Now you think that LFS, let me get this straight. After reading Rust for the past 30 minutes, chat now says they want me to read all of Linux from Scratch manuals. Are you serious right now? Y'all are nuts. Oh, Lord. Do we read LFS out loud? What do you want me to do here? Because I don't know anything about LFS other than it sucks to read a bunch of stuff. Oh, God. You know I'm not going to cut up this stream. Let me just make one thing stream here. I don't do clips. On any live stream, if you want to get that fancy clip or like, let's say the Reacts video in the middle of this, I don't do clips anymore. I'm just like, hey, I ain't got time to do that. I'm just uploading these entire streams to YouTube afterwards, and there's enough people that watch the whole streams that I'm just like, hey, that's good for me. I'm not going to clip it. So we're not doing content, so to speak. We're just doing what you all want, because I want to make the streams as entertaining as possible. And I find it hilarious that everybody's saying LFS right now. God bless. Do we even have a second option here? Highlight. Titus reads chapter 3 of the Rust manual. It's literally the only thing chat has given me is LFS. So there isn't even a poll to do. Y'all just want LFS. Okay. Y'all are masochists. Linux from scratch.